definitely explain the things much more in a vivid way. I think not few, rather, all of you already have virtually met the teachers related with your third year, first semester laboratory experiment on illumination engineering. That is spectral compositions of different light sources and the measurement of CCT. And few of you have met, I also was attending with all of you with this, that in a physical mode. But I think all of you already have met with the faculties with virtual mode, especially for this spectral composition of different light sources. So if you have gone through the syllabus, first of all, two, three things before I start my today's class, I want to share with you that at any part of my discussion, if you have any further query, feel free to contact, feel free to interact and start interacting. So, even once we will meet, I am very much hopeful, possibly in the month of February, if the situation is getting restored, we will meet in a physical class. But definitely, we all are hopeful in that case. Then also, I would like to have a lot of interaction in between the classes, because this subject is very new in that aspect that lots of research scopes are there. This subject will definitely motivate us to see the different aspect of electrical engineering and its utilizations and applications. So we have to be a bit accustomed to it. At the same time, the first part of the subject will be mostly talking about few fundamental definitions, some few fundamental concepts of physics, and also some basic themes of electrical engineering. Maybe the initial stages will look a little bit confusing because we will be introducing some terminologies which are very new and sound similar. So I will rather ask you that don't go through the subjects like that. Mostly go through the way we are basically explaining the things. Try to visualize the things. So it will be much more easier for us. So that's why even in this online platform, I expect a lot of interactions from your end in between the lecture, after the lecture, no matter whatever may be. Number two is that the very sensitive part of the curriculum, we need to go through that the textbooks. Let me tell you very frankly, this subject is so new. We don't have any Indian author, neither we have a dedicated textbook which I can consult or refer to you. So that's why what I will be preferring, that I'll be giving you different portions, whatever I will teach in your class, in online or also in the offline mode. I'll be referring the different books, and I already have this book because those are the written by the foreign authors, and it's a very costly book. We have some copy from our department. Your CR, maybe Danish or whoever will be another CR from your end, will contact with me so I can share that textbook. So the part of the textbook from where I'll be going to refer the topic which I'm going to discuss. So that is why. And in some cases, as already I've told you, it is a research-based topic also. So that's why our normal textbook will not help us. In that case, we need to refer some kind of research publications or the journal papers for our references. So that also I will be referring. So don't be afraid of that. I'm going to tell you something very exclusive. I'm telling you that for this case, the all reference document, and unfortunately I can't provide you the notes. I'm not that strong, and I'm quite lazy to prepare a note, so that's why the note will not be possible. The only thing, I have prepared a PowerPoint presentation because I've got forced to transfer in this online mode since last 2 years. In a classical classroom lecture, I always prefer chalk and talk, but this time I am helpless. So that's why I have prepared a PPT. That PPT I will be sharing with you, but that will be just a framework or a guideline. The corresponding reference textbook and the different foreign authors book, in the different books I'll be referring after my every lecture. So that is a modality which I am going to follow. I hope it is clear to all of you. Now let us talk about the discussion. We are a little bit lagging because I was suffering from COVID. So I just recovered. So maybe I need to take a little bit break in between the lectures because I'm not absolutely fit now. So let us start talking about the field illumination engineering, what we have. So in the next day onwards, we will be going in the detail, but today we are going to talk about something related with the entire subject you should know, entire syllabus, entire curriculum. I hope you already have the curriculum with you. So if you go through the curriculum, you will be going to see the different aspects. So that's why I think in today's class, we will be talking this field as a whole. So basically in this topic, we are basically have two fundamental components. One we call classical approach, and the next module will be a new approach, a paradigm shift, which we call human-centric approach. So what is there? What we have in this subject, illumination engineering, what it means? So we already have gone through some fundamental physics of light in our very earlier days. From the very, maybe the class 8 or 9 books, we have physical sciences where we have defined the physics of light, light as wave, light as particle. So we know the wave theory as well as particle theory, and some natures are basically very much contradictory, some natures are very much assisting with each other. So that's why finally, if we go through the de Broglie's hypothesis, if we go to the unified theory of unified, so it is basically an electromagnetic wave. There is no doubt about that, but it's have a particle nature as well. So that's why we also define light as a bunch of particles or photons. So this is the fundamental physics of light. That means mostly the way light will propagate, the different properties of the light, whatever we are going to explain. Few of the properties can easily be explained with the help of physics and wave properties, and few of the properties are, as we all know, that is we call it's a particle property. So that's why the quantum theory and de Broglie's hypothesis in 1924 talks about the basic physics of light. So as we know, the semester is not big because we need to cover up a huge portion within this curriculum. So that's why I'm not going to spend too much of time on the physics of light. But if you are particularly interested with any specific area during your study, your references, just feel free to talk with me. We can extend our lectures. Otherwise, I will be going through the basic flow of light. Physics part not being that much elaborately discussed because we already have gone through this basics of the physics of light. We have also the optics. Now the question will come in your mind, the physics of light, the optics, how that is different with illumination engineering. This is a area of electrical engineering. So here we, the electrical engineers, are more interested about, sorry. By the way, sometimes I need to interrupt and ask whether I'm being audible or not, because you know, in this medium, this is very difficult to know whether I'm still connected with you through internet or not. So I'm audible, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, thank you. So let me continue then. So here, basically, if we can talk about that, the light as optics means it's basically the controlling of the light. So the light which is coming out, maybe a single ray, maybe a bunch of rays which are coming out from a source, that basically used for sake of measurement, used for further processing, used for redirecting. So those calculations, those analysis, those physics are mostly coming under optics. Then what is the role of illumination engineering? Definitely we will be searching. It is very difficult to give this answer with a single node. So that's why we will proceed slowly, and due course of our journey with this subject, we will be understanding what is the actual significance of illumination engineering and why now throughout the globe, if you are, I know that you are quite advanced now. If you Google, if you search for what is a recent research area, research boom in the United States as well as European countries, you will see illumination is one of the top, because many more areas are yet to be definitely cultivated. So it's not all about the source, light source itself. This is very important, that how you are using your source for sake of your requirements, human requirements. You might be thinking that since my childhood, we all have gone through that light is required for a space to see some object. So let's put the light. Where is the speciality that my local electrician, in a very lighter note, I am telling you, my local electrician who used to put the lights in maybe in our puja pandals, they are very, very effective uh, people who knows about the illumination. This concept with which we all have to some extent grown up. But with this process, actually, the question will come whether it is after all that. Is it only to put the light here and there and to ensure the human visual performance? No. We need to ensure the different aspects, which starts with the human visual needs, electrical source, which will definitely ensure the human visual needs. But it's not only the human visual needs, also there will be something beyond the human visible visual needs. So what is that? So this is something like that. Just a simple example I can tell you. Uh, it's a post-lunch session. After 2 p.m., I am taking a theoretical classes of all of you. This is what happened with all of us in different course of time. No matter how interesting topic I am talking about, no matter how interesting way I am delivering, it may possible that you will feel a little bit sleepy. Why? Because in your human brain anatomy talks about that during your post-lunch period, you will be a rush of hormone called melatonin in your body, which to some extent triggered you to go for a sleepy mode. So what is the remedy then? How can I motivate it? A very good lecture definitely can motivate, but sometimes we do take a different approach. Just way we start asking the question to individual students. Maybe sometimes I say, see, today what I am going to talk will be very important for your semester examination. So everybody will become alert. Now, what from where this alertness is actually coming? So if you go to the root of that, you will find in our brain, we have another sort of hormones called cortisol, which is an activation hormones, will make you more activated. Now, there will be a rush of cortisol, which will dominate over the melatonin, and that's how you will feel activated. The question is that if it's so, how this light system can work? So the root, I already have talked with you, that is an auditory stimulus. If I ask you by name, say, Danish, right now tell me what is going on. Just for your better understanding, I can say you, uh, in last September, I was engaged with one UGC courses. And there I have seen from a very renowned professor from one institute of higher education from, say, government of India. So he was delivering his lecture to the different speakers, and after a few minutes, he realized everybody become numb, because this online mode. What happened? Always everybody is not alert. So then he started asking the whatever was content there in his slide, asking by name of the individual faculties. Say for an example, he asked me that, Dr. Shuddhata Chakraborty, you tell me what is there written in the slide right now. So what is that? This is a sort of auditory stimulus to me. Now the question is that light have a very, very important role to trigger that, what we call human-centric lighting. So definitely with due course, we will be going through that journey. So the light will be used for sake of your visibility. There are lots of calculations. There are lots of mathematics. There are lots of equations. But at the same time, the classical approach will focus about your visual needs only. And in my next model, that is a human centric lighting, a paradigm shift. So there we'll see how the non-visible effect of light can be introduced. Just the example I was telling you, the post-lunch session, the classes, you all are feeling sleepy. If the lighting condition is changed to something else, maybe your performance can change. We will be discussing about that. I'll be sharing my own research. Even it has got established many times by mapping the human brain activity using different type of devices like uh, EEG based study. I think you'll be knowing about that, electroencephalography. So this is a very old technique, but now with a good, better way of signal processing, we can identify how human brain actually reacts, and we can establish the fact whether the light spectrum, whether the amount of light have a real effect on human performance or not. Next is a very important part is that this is, now you might be thinking that, sir, why you are talking about this, the human centric lighting, human factors in lighting. In a later part of our curriculum, we will be talking, not in earlier classes. After finishing the classical approach, we will be going to that. The most important question is that why so lately? Why in 2022 I am talking about that? I can share with you that, say, 14 years back, once I used to teach the same subject to the third year students, I was not saying so much about the human centric lighting. Why? Because on that time, whatever I had in my scope, the LEDs didn't available with this thing. It is a magical source. We'll be talking a lot about the in favor of LED, something in against of LED, but definitely that LED is something which is basically, it's had something which we can't ignore. So what is that? Sorry. So this is basically the controllability. I think you all are now quite conversant with this term IoT. We all talk about everywhere, in every platform, every domain. And if you Google that, in even in Amazon, if you search, there are the bulbs available which can easily be controlled through your mobile phone. So you have a light bulb made with LEDs, and instantly using your mobile phone app, you can change the color of the light, intensity of the light. You can integrate that with the outer ambience. So that means all possible controllability you have rightly available with your mobile phone and internet based system. So that is a highest level of contacts we have, highest level of controllability we have. So that is, as this thing is possible, now the things are becoming much easier to control the lights. So if this is possible, then the question will come that how human brain behaves with the different lights, that we can identify, we can investigate, and we can design. At the end of the day, once you are basically designing, due to course of our discussion, we will be coming definitely in those topics where we'll be talking about that, how that your light can integrate it with your performance. So finally, light is required not for empty space, it's for human being. And so far, the classical approach is focusing about the human visibility. But the paradigm shift, my module 2 will be talking about the human-centric approach, which will talk about take care of the human visual needs, but at the same time, how different light, different lighting condition, the spectrum, the color, that influences your brain performance. How the stimulus, the visual stimulus of light is getting processed in your human brain, that is also under very much consideration today. 20 years back, people hardly used to think about that, because 20 years back, we really didn't had any sorts like LEDs, which are much more easily controllable. But now we have this thing. So that's something very easy. Think about in your childhood, you hardly used to think of some fluorescent lamp or incandescent lamp or compact fluorescent lamp. Beyond that, you hardly have seen a light source which can be instantly changed. The color, the intensity can instantly be changed. So this is quite not available there. So that is something we definitely very much be aware of, that in illumination engineering portion of this utilization classes, we will see that advancement. We will see how the lighting control can be established also. So if we think about the electrical requirements of the lights, that is also a very important source. I can share one thing with all of you that say uh, 20 years back, once we used to go to visit any forum for our own research to deliver some topic, we have seen that the energy efficient lighting, energy efficient illumination, energy efficiency and power system. So those were the topic which was being discussed in different seminar conferences, because there the main concern was to save the electrical energy. And you will be surprised to know that the maximum potential already we have in electrical energy context is a lighting, which is a neglected one. Generally we don't think of, but it consumes 20% of the total global energy. And the interesting part is that this statistic says that some of the light sources are continuously running for a longer period of time. Best example, we all know street lights. Have you seen any day we are making street lights should be made off? No, there is no such schedule. 365 days throughout the year, this definitely will go on. So that is, we need to always say that the huge energy saving potential is placed within that. So if we can have a proper control over that, so definitely we can save a lot of energy. So that point we definitely take care of while we are designing a system. So how your electrical system can be controlled, how your based upon some sensors. The sensor may be, say, the light sensor, which can sense the availability of the light in outside, availability of light in your space. It may be something related with the light as well as human occupancy. It can be connected with the different seasonal changes. So that's how we will be talking about the evolution of lighting control system, which was started with a very fundamental, very old analog control system, 1 to 10 volt analog control system, which is a very traditional one. And then now today we have the smart systems, we have the internet based control system. So my 1 to 10 volt analog control signals are now getting replaced with a IPv6 packet protocols, a packet of data. So that's journey we will be definitely talking about. As this journey is possible, we have enough energy saving potential, we have enough resources to explore that whether we can accommodate the human visual needs. Human needs, visual needs is a separate thing. We will be jumping to the human needs, we will be focusing of that. Beyond your visual requirement, if we can ensure the human performance, that is the best example. So that is why our illumination engineering as a subject will start with the light source you are considering. Then definitely there will be a part where over which my light source will be placed. That is what we call light fixtures. In a colloquial term, technical term is luminaires. So we will talk about the different luminaires. Then we will talk about the lighting design. Apparently, we think lighting design means put the light here and there. It's not the case. Lighting design means it starts with the selection of light source, selection of the luminaires appropriate for the light source, and to positioning it properly, and lastly to make a control over that. So everything is very much predefined. Sometimes in some makeshift arrangement, we see just an example. I already have told you that in your local puja pandal, you will see it is done in a temporary basis, but that is not the case. I'm talking about a very simple example. Another example for your better understanding, I can try it. That is, we all enjoy the sports. We all enjoy Champions League. We all enjoy the IPLs. So once you are having a stadium, cricket stadium, so I'll be sharing my own experience as I have got associated with the lighting design of Eden Gardens, our very famous one. So there you will see the sports field itself have a different requirements of the players, requirement of the officials like this umpires and other, now we have different officials, requirement of the viewers, and requirement of the viewers who are far away from the arena, like all of us will be say placing ourselves in our bedroom and start enjoying that match. So that means a camera. So that's why, see, the evolution has started long back. So during 1980s, once the cricket match or the football match or the sports, particular sports was got televised, now has changed a lot. On that time, the question will come that whether it is a color televised or not. But now, this is whether HD or not. You will be able to see in your television that how accurately some match is getting played. Every inches of grass you can see clearly. But if you don't have that lighting design in your stadium, just let me tell you very frankly, this is quite impossible to have this. So that's why this is a real challenge for a lighting design, especially a sports lighting design. It's not that we'll put the light here and there. We have to go through different design parameters. We need to calculate that. Um, I can share one more thing, very interesting example related with that stadium lighting, because those individually we will come in the coming days. But today in an introductory class, I thought that I should have explained the entire journey we have in ahead. So that's why I am referring that examples, many more examples, such a way you can relate a bit. Let me come back to that example of cricket stadium, that our Eden Gardens. So two aspects. One, we are talking about the lighting requirements for the players, the officials, and viewers in the arena, away from the arena, and the TV cameras. So those are the four stakeholders: our designer, lighting designer, an electrical engineer who will be designing the lighting scheme should take care of. So that's why in our Eden Garden in 2010, a special type of luminaires were used. The quality of the lamp was very, it's an imported one. The manufacturer was Philips, and the name of the luminaire was Arena Vision. What was that with the Arena Vision? So it was, the beauty was that the luminaire was so specially designed, all the lighting requirements as recommended by the different standards were actually to some extent was made up by the designer. Just here we have, in a cricket field, we all know there is a pitch area, we have the boundaries, we have the different fielding positions. So for every activities, the recommended light level is already standardized. Who has standardized? We will be talking about that. Individual lighting application, they have the standards like CIE. I'll be referring in coming days many times that term, CIE, Commission on Illumination Engineering. So they are the highest European body, and now throughout the world, everybody is very much following them. So CIE, International Commission on Illumination. And there is an American body who are also providing different type of standards and recommendations. We call IES, Illumination Engineering Society of North America, IESNA. So CIE and ISNA, I'll be referring many more times in the coming days. So CIE will be mostly talking about the European, but now the entire globe follow them. So all the global standards are to some extent at part the CIE. I'm also a member of CIE in that context. So, but what CIE and ISNA, those standards are doing, like we have our own Indian standard, Bureau of Indian Standard, BIS. I think you will be quite knowing about that. In everything we do purchase electrical or maybe any product which is non-electrical type, maybe a paint, there is a BIS standards also. So in this way, the CIE is the biggest or global standard, international standards, which we do follow. But apart from that, for the sports lighting application, for every sports lighting, there are specific standards offered by the individual authority. Authority means for cricket, we know ICC. For football, we know FIFA. For hockey, International Hockey Federation. So in this way, every sports, they have the authority, they have their own standards and you need to follow. Come back to that again, Eden Garden example, which says that in pitch area, you have to maintain a light level. So today in an introductory class, I am not using the parameter, technical parameter, which is used to indicate the light level. This is we call illuminance or lux. But today, if I say many times, you will get confused. I'm quite confident that within coming days, we will be much more conversant with that term. So illuminance is the parameter which we use to indicate the light level in the pitch area. So here the unit is lux, L-U-X. So here, according to the ICC guideline, for pitch area, we need to maintain only for the pitch area, we need to maintain a light level of 3000 lux average. So average means in pitch area, we will be placing different grid points, and at each grid points, we will be counting the light, and that's the average of illuminance at each point will be taken, and that should be 3000 lux as average. And the uniformity, that's measured like minimum value of illuminance to average value. So mean by average ratio should not be less than 0.95. Think of that, how almost the peak will be 3000 lux illumination and uniformly distributed, almost 100% uniformity. Now, the designer have started doing the design, the electrical engineer, so he has started putting the lights, different lamp luminaire combination, and finally he put that. At the same time, in a standard, it was mentioned that your boundary area light level should not be more than 1200 lux. Why? Because if it is going more, so the player cannot see the high-rise sketches. So that's how the design was made, and 3000 lux was achieved in the pitch area. But during the play, the players start complaining that we can't see the high-rise sketches. So that's why there was many more misses of the high-rise balls. The reason was that because after that match, the light level in the boundary area was measured and it was found it has become 1800 lux. So that instantly the electrical engineer who was designing that sports field, he started reducing that boundary area light from 1800 lux to 1200 lux. But at the same time, the light level in the pitch has reduced. So I am just want to show you that how complicated this job was to optimize that. So once you are going to reduce your boundary, your pitch is getting reduced. So once you are going to increase your pitch, your boundary level is absolutely becoming higher. So that's why the design was very difficult almost. So that's why this type of dedicated luminaires were developed, which is a very specific one. Its distribution, and we will talk about that. So it will redirect the light in a very specific way. So that will help us to see the things much more clearly. Now, the challenge was very interesting. The Arena Vision luminaire as individual lamp was almost 2.7 kilowatt. Can anyone help me by calculating that? Say an individual lamp, metal halide type of lamp, we will talk about that lamp in the coming days. So individual lamp power consumption was 2.7 2.7 kilowatt, 2.70 kilowatt. And in our Eden Garden, I think you have seen we have 4 masts where the lights are placed. So each mast having 130 number of luminaires in average. So how many luminaires are there then?
520.
520. Now
520.
520. Now you calculate how much power your Eden Garden consume during every matches only for sake of stadium lighting. There are other lighting for the audiences, the the offices, the CAB ground, and the pavilions. That's I'm not considering. Only the lighting load for the sports field.
So
Can you
1.4 megawatt.
What? 1.4 megawatt.
exactly? So
1.4.
150 into 2.7 approximately. So think about this one almost 2 megawatt of load, which is not a small thing. It's almost a city. Some city also the entire load consumed by a city sometimes goes something in this range. So a single stadium during match, it consume at least 2 megawatt for sake of stadium lighting, and you have the other loads, air condition loads, other accessories we have, the pavilions, the dressing room, the audience gallery, every the other loads are there. So it's almost it consumes something in a range of 3 to 4 megawatt of load. So that is why it is very essential to control that. And the interesting thing is that individual lamp is 2.7 kilowatt. So if you operate with a 230 volt single phase supply, what will be the problem? What will be the fundamental problem?
Sir, it takes huge amount of current, so conductor
Right.
cost
So
is very high.
if you have a huge current, then where will be the problem? Sorry.
So the wires will be
Loss will
very
be
thick.
less.
Yeah, and the immediate effect will be there will be lots of I squarer losses, and there will be huge heat. That is unmanageable heat. So if you have a huge amount of current, you can calculate 2.7 kilowatt each and operate it with the 230 volt. A huge amount of current is drawn by it. So to reduce the current, what was the solution? The solution was that the
So
lamp,
increase the voltage.
yeah, increase the voltage, but that voltage should not be something operated with the transformer because you have 520 number of lamps. So it is not possible to operate them using a transformer. So because this will be an additional burden. So the thing is that let us introduce, we are dealing with the 3-phase supply. So 415 volt, if we can introduce, to some extent, we can reduce the operating current. So that's why 415 volt, that means we know the RYB 3-phase. So there is a combination of 2 phases at a time. So that means maybe for luminaire 1, I have R and Y phase. So it's a 415 volt. Maybe for the next luminaire, it's a B and Y phase. So in this way, entire loads are balanced with the RYB combination. So that's how we are giving it's a line voltage and phase voltage relationship. That's why we are making it 415 volt. But as an electrical engineer, this is very challenging. Why? Because it may happen that your players are practicing. So it's a practice match. So in that case, neither it will be get televised, nor the officials will be there, nor the viewers will be there. So in that case, you need to reduce down the load. You need not to make all the 520 number of luminaires on. Only the luminaires which are required for the field and players can see only for sake of their practice, those will be made on to reduce the energy. So if I make it on and off, so there will be a huge chances of imbalance in the load. Are you getting my point? So
Yes, sir.
there is a chance. So that's why I'm just telling you how critical the job for an electrical engineer to do this design. So it's not only put the light here and there, that needs the calculation. And after all, once you are doing something, you have to ensure the lighting requirements as well as you have to take care of the electrical parameter too. So that's why we'll be very much focusing about the electrical parameters, and that's how the electrical parameters will be optimized. We will be controlling the individual lamp, and we have to take care of the issue that once the practice mode will be made on, there many number of out of 520 luminaires, maybe only 100 luminaires will be made on. So if I am going to make it on, the possibilities will be there because the lamps are operated with R, Y, Y, B, B, R in this way, a proper sequence. So if there is a change of the sequence in this way, possibilities will be there, a huge unbalancing in the system. And it's a huge load, huge current. So unbalancing in a system will be a difficult parameter there. So we need to take care of. So this is some example. So that's why lighting design itself is a very critical affair while we are going to we are going to practice, we are going to explain. And lastly, the lighting control I have told you, and how the human-centric approach will go. So that is a overview of our illumination. So that means it will start with the light source, different type of light source, the terminologies which are associated with the lighting. Here we'll be talking about some coordinate systems also. There will be a better understanding of coordinate systems. And after that, we'll be going through some very, very delicate area like how the light can be measured. That is what we call photometry. I think in our last semester, we all have gone through third year, first semester, that experiment. Now, even in the third year, second semester, I was hoping that again we will meet in a physical mode in our laboratory. Few of you possibly have visited our dark room. So there, the measurement we are doing is basically called photometry. So the measurement of light is very important. The photometry can further be divided is one or two way. One we call visual photometry. That means once we are using human eye as a sensor. If you can recall back your class 2 level physics laboratory classes where we have used lenses, we have used mirrors, we have used prism, but human eye as a sensor, if we have performed any experiment related with the optics. But now, once the human eye is getting replaced with an instrument, photoelectric instrument, a meter, just the way I was telling you, the lux meter. So the value will be something different. So it will give me a value of physical meter. So human eye is replaced with a photoelectric instrument. That's why we call it a physical photometry. So we'll be talking about that measurement of light in that way, the photometry. And after that, the lighting design and lighting control, and we will conclude with the human-centric lighting. So this is all about the action plan we have for our coming few months curriculum. So if you have any query under this situation, whatever discussion so far we had, you feel free to discuss now. Otherwise, I can start the next session. Any doubt, any query, anything you want to contribute, or any discussion you want to initiate?
Sir, in case of stadium lighting, why metal halide is used instead of
Right.
LED?
Actually, right now I can tell you the answer, but just as you asked rightly, it's a very interesting question. It's a very good curiosity. I can give you the answer. I will give rather. But again, we will be going to those parameters which much more detailed aspect. But it is the LEDs are now getting replaced. I am telling you, I was told you that in garden lighting is now under me, SM Madam or HD Madam, both who are to some extent involved with that project. So there, the Eden Garden is even getting converted with the LEDs. The advantage of LED is basically it's an instantaneous switchable. It is a more easily controllable. You know that main challenges throughout the world, the stadium, which are mostly illuminated by metal halide lamp because of the color property. The metal halide lamp was first introduced in sports application during 1968 Mexico Olympic. Before that, all the matches were played under sodium vapor lamp, yellow color light we used to see in our street light. Now that is also getting replaced in our city also. So now that metal halide lamp, the advantage is that the color purity, the color is very good, which we call color rendering index. We'll be explaining the term in the coming days. So that's why you can have a better color. So you can see the object. Even sitting at your home, once you will see, you will feel, enjoy the Champions League, you can see every textures very clearly. The color of the jersey, the every textures is very much easily visible. So this is because you have a good color property. And I think last semester experiment, whatever we have performed virtually as well as physical mode, we have seen the color property will be very much decided if we have the colors present in the spectral composition of a light source. If light source doesn't have the color present in its spectrum, how it will show its the color? I hope you all have virtually attended the class, that laboratory class.
Yes, sir.
We have physically done also.
That's very good. So you have seen the yellow color, low pressure sodium vapor lamp or SOX. So it was a very poor source. We have seen only golden yellow color was there because in spectral composition, rest of the colors were not present. So why I am referring that? Metal halide, we will see something much more improved picture. I'll show during my lecture the whatever is measured in our laboratory, some real data I will be going to show you. So there we'll see all the colors are there. So that's why the metal halide was introduced. But what are the discomfort with this metal halide system? The one of the big discomfort was the switching. You may have any interruption in the power system. It's quite feasible. You know, there is a fluctuation in your power circuit. So if it happens, your light, stadium light will get made off instantly. For metal halide lamp, it will take at least 20 to 30 minutes for reignition. Actually, the lamp filament, whatever we have, the electrode and the assembly placed within the glass bulb, we will talk, that needs to be cooled down again because it's operating means it's very much hot. So once it is hot, it cannot reinitiate. The chemical composition of this metal halide lamp demands that lamp is required to be made cool, and after that then only it will be able to restrike. So that's why the restriking time is very high. It's 20 to 30 minutes. So as it is 20 to 30 minutes restriking time you need, so that's why the chances are very much that it will take 20 and 30 minutes and your entire stadium will be under complete darkness. So that is why LED is doing the marvelous job. It's an instantaneous switching because we all know this is nothing but a PN junction. So that's why once your power has got restored, maybe you have a power fluctuation. So once the power has get restored, it can immediately see. So that is the main advantage with the LEDs. So it can reinitiate the process, restrike the process so fast. But what was the challenge with the LEDs? In your fourth year, you will be happy to know that honors paper, we have solid state lighting part, where we do talk about all things, all technical parameters associated with the LED. There we'll see the main challenge with the LED is the thermal management. So here we know the junction temperature of the LED is the main enemy because it's a PN junction, just like a conventional diode. And the heat which is getting accumulated or generated at the junction because of the electron and hole recombination, that heat will be required to be eliminated. How that heat can be dissipated? The heat can be dissipated with the help of some mechanism which we call heat sink. So, but that is a great challenge. So that's why lots of research is going on to have a very efficient thermal heat sink, and that can help you to liberate or dissipate the heat at earliest. So that's why higher and higher wattages, heat will be much more high. So that's why it will be a great challenge to dissipate that heat. So keeping that point in mind, we need to think it differently. Okay, so that is why it was a real challenge to have a high wattage LED, but now this is quite feasible. You can have more than 1 kilowatt of LED luminaires. I can tell you 5 years, 8 years back, it was quite impossible, but now this is quite possible. So that's why the stadium lighting luminaires are replaced with the LEDs. But that will be evident because if you have LED, you have enough controllability, it an instant switching, and the color and intensity, everything can be controlled accordingly. So that is why the LEDs are now very much well appreciated for the stadium lighting as well. Is it clear?
Yes, sir.
Anything else? Anyone? So, just this portion with which I will conclude that apart from the physics of lights, there will be a part, the generation of light can be classified in two ways. One we call incandescence phenomena. So, light is passing through a conductor, it will get heated up and some amount of energy is getting converted as light. And rest of the family by which we are getting the light comes under the luminescence. Luminescence, that means a simple example, if we talk about the fluorescent lamp or something, there the discharge lamp is there and electrodes are there in between, so the gas will completely get discharged. So that comes under a type of light generation. So that is what we call luminescence. If we can talk about the solid state light, like if we can talk about the LEDs, so their electron and hole will definitely recombine. So that is also another part. So this is another way how the light will be generated. So that's all, the entire umbrella on which we have, other than the incandescence way light will generate, that comes with the luminescence. Okay, so that is what we call incandescence and luminescence. Any other way we are generating the light, we can definitely take them under the subset of luminescence. It may be a discharge lamp, starting from fluorescent lamp, compact fluorescent lamp, metal halide lamp. Those are the gas discharge lamp. You have an electrode and you have a glass or a envelope with which we are allowing the ionization of the gas, discharge of gas, with applying a high voltage across electrodes. So that is a family, discharge family. We have solid state families like LEDs, where the just PN junction electron hole will recombine. So that's how the incandescence and luminescence family can be segregated. So in the coming days, we'll be talking about the different applications with the luminescence. We will be explaining them individually. So for incandescent family, we need to refer the black body radiation also. So I think for our today's introductory class, we can conclude over here. So if you have any query, next day we will start with the black body radiation and the human vision, how they are related. So if you have any query, feel free to ask. I hope you don't have any more query. Debarko, you said something. Does light effect on the brain change with the age of the human? Does this kind of topic is a part of the? Yes, yes. It's basically, definitely, as you said, it's a topic of illumination engineering. We need to do more and more research on that. That's how that actually processing with your brain activity. So definitely, it is very difficult to say what is the effect. If you ask me, because this is under lots of research, so that's why I can't tell you with a single statement that what is the exact effect, how that at all affect, which spectrum actually affect. But definitely, this is a topic which we can have a lot of research. Okay, Devargo? Anything else? So next day onwards, we'll be talking about the black body radiation laws, and then we'll be going to some more important parameter about the human eye and related with the black body radiations, how they can be made relatable with each other. Okay.
Okay,
So
sir.
if you don't have anything else further asked to, otherwise we can conclude over here. So next Wednesday we will be having our class, but by that time I will talk with Danish. If we have any more further free slot, I'm available. You are available also. We can take some classes more. Okay, Wednesday
Okay,
this
sir.
time classes is confirmed. Next week also I'll be going. Yeah. So if you do you have any more query, otherwise we can conclude our session over here.
Sir, shall we enter name and roll number in the chat box?
Yeah, actually, you can, Danish, you can do one thing. You can make a list and send it back to me. Already the entire lecture session was under recording, so I can see who were present at that time. This is very much available. But still, I prefer that if you can make a list and send me, because from the chat box, I can read it. But if you, on my behalf, if you can make a list and can send it back to me.
Okay, sir.
Okay.
Okay, sir. Sure.
Any query, anything? Otherwise, we can conclude over here.
No,
We'll
sir.
see you in the class.
Sir,
Thank you.
shall I send you the screenshot of the this class of number of students present?
Yes, you can make it. So if you can have the screenshot already there with you, you can make it. Or whatever will be convenient for you, you can do.
Okay, sir. Sure.
I am not spending too much of time by calling the individual roles in this way. That is a traditional way, because in the chat box it takes lots of time to read.
Yes, sir.
Okay. So thank you. See you
Okay,
in the
sir.
next
Thank you, sir.
class.